Okay, special right triangles. We get to use some shortcuts to solve these problems. And our answers are going to be in exact form, so our answers will have radicals in them. First problem, think of this as half of a square. So the 2 square roots of 6 is the same on each leg. And the y is always times the square root of 2. We're going to use the formula x times the square root of 2. So we're always going to take one of the legs in a 45, 45, 90 triangle and multiply it by the square root of 2 and then simplify it. So we have 2 square roots of 6 times the square root of 2. This is our x in our formula x squared roots of 2. And there's our square root of 2. And then just combine together what you can. So I'm going to put together the square roots, the radicals, and make that a square root of 12. And we'd be done if we couldn't reduce it, but we can. We can simplify that square root of 12. I'm going to think of this as the square root of 4 times the square root of 3. The square root of 4 is 2. So I have the 2 from here times 2 times square root of 3. So my final answer is going to be 4 square roots of 3. You could have done the tree here with the 12 also. 4, 3, 2, 2, if you prefer this method. And then circle 2 2's and pull them out. It becomes a single 2 on the outside. So that square root of 12 is 2 square roots of 3. And then we have the other 2 to bring down too. Either way. Next one, now we're going in the opposite direction. So we need to divide by the square root of 2 to go to both of these. So 8 square roots of 6, divide by the square root of 2. 2 ways. The longer way, you can see you have to rationalize the denominator. So 8 square roots of 12 over 2. Reduce this to 4 square roots of 12. And then do the same thing we did in this other problem here, where we found out that the square root of 12 is 2 square roots of 3. So I have 4 times 2 square roots of 3, which together is 8 square roots of 3. That's the longer way. There's a much quicker way to do this. So I'm going to erase this. Pause it if you need to. It makes more sense to me when I do 8 square roots of 6 and I'm dividing by the square root of 2 to right away notice that the 6 and the 2 reduce. So you just cancel those and make it 3 and 1. So I just have 8 square roots of 3 over the square root of 1, which is just 1. So that would be much quicker. So if you notice you can reduce things ahead of time, go ahead and do them. And then one more. Here, we're going backwards. Oh, this, I'm sorry, back on the previous one. This is x and y, because they're both the same length. Both x and y now, again, divide by the square root of 2. Here we don't have a choice. We cannot reduce the 18 and the 2 because one's under a square root and one's not. So we have to rationalize because we're not allowed to have a square root on the bottom of a fraction. Multiply straight across, we get 18 square roots of 2 over 2, the square root of 4, which is 2. Cancel ahead of time if we can. If we had to reduce this part of the problem, that square root of 2, like before we had the square root of 12 there, we'd reduce that, but we can't. That's just going to be our final answer. Now the next part, these are a little trickier. We have to use this formula here. If this is x, this is 2x, this is x squared roots of 3. So I have that written down somewhere. Now on the triangle I have written right above it, it's flipped around. So this is lined up like that one is. So be careful which way this is facing if this is a 30, 60, 90 triangle. Okay, and this one here, we have the x, we have the x squared root of 3, and the 2x this way. The way you can memorize this is just imagine this being part of an equilateral triangle. Okay, and if I have an equilateral triangle, if this is, let's say, 10, 10, and 10, well then this must be a 5 and a 5. So when you look at this part of the triangle here, because it was 30, 60, 90, well this is, or it was 60, 60, 60, now it's a 30, 60, 90 triangle here, and this little piece here is half as long as the hypotenuse. And that's how it works here. This piece right here is half as long as the hypotenuse. The straight up and down side, or the height of the triangle, however you want to look at it, is always times the square root of 3 of the short side. So that was just a quick overview of that. It's just a matter of doing the problems. Going from here, we're actually going backwards. If I was going from x to that side, I'd go times the square root of 3. So coming back, I'm going to divide by the square root of 3. Oh, I'm sorry. I switched it around like I did before. That's just twice as long. So here I'm just dividing by 2. I hope you catch it like I caught that, because common mistake. This is twice as long as this piece right here. So if I just take 8 square roots of 6 and cut it in half, I'll get 4 square roots of 6. That's it, unless you can reduce the square root of 6, which we can't. Then to get y, we're going to multiply that answer going this way times the square root of 3 to go up from x to y. So this is x. Y then is taking that 4 square roots of 6, multiply it times the square root of 3, and I get 4 square roots of 18. I'd be done if I couldn't reduce it, but I can reduce this. I'm going to think of this as with perfect square numbers. So square root of 9 and square root of 2. Square root of 9 is 3. I still have the 4 out front, so my final answer is going to be 12 square roots of 2 for y. Okay, to the next one. Here I have x, and it's just a matter of multiplying then. If I have the short side, we just multiply. So going to the diagonal side, I guess I'll just double this side. So this is 2 square roots of 2 doubled, so times 2. Now when you double things, or when you multiply by whole numbers, only multiply the whole numbers together and the radicals together. So y then is 2 times 2 square roots of 2, I guess you could rewrite it that way, which is 4 square roots of 2. And then for x, we're going to take that 2 square roots of 2 and multiply it times the square root of 3. That's what we always do, go in that direction. So 2 square roots of 6. If we could break down the square root of 6, we would, but we can't. So that is our x. Finally, going from this straight up and down side through there, I'm not going to go to x, I'm going to go to y first. I'm going to have to divide by the square root of 3. So I'm going to go 24 divided by the square root of 3. I look at that, I cannot reduce the 24 and the 3 because one's under the radical and one's not. So I don't have a choice, I have to rationalize because there's a square root on the bottom. So I get 24 square roots of 3 over 3. Now I can reduce the 24 and the 3 this way. I get 8 and 1. So we get 8 square roots of 3. And then going from that 8 square roots of 3, which is over here, to the x, I just double it. Because this x is always, the hypotenuse is double the length of that short side. So 8 square roots of 3 doubled. So let's go times 2. This was y, and this is x. Is, again, just combine those two together. So we have 16 square roots of 3. Do not make that 16 square roots of 6. Don't combine the 3 and the 2 any other way, because one's a radical like this. One's a radical and one's a whole number. Don't mix them together. That should be about it.